Hello everyone, welcome to this course on geometry brought to you by Azuric. My name is Nitesh Dutt. In the first few videos of this course, we will be covering everything about triangles. So this video is all about basics of a triangle. If you already know what a triangle is and you can understand some basic triangles like isosceles equilateral triangle, you might as well skip to the questions given at the end of this lesson. So we will be covering these three important points here. What is a triangle, its classifications, and some basic properties of a triangle. And at the end of the theory portion, we will be solving some questions based on the concepts we have learned. So let's start from the definition. What is a triangle? Now a triangle is any closed surface which has three angles or three sides. Now I hope you understand what an angle is. An angle is this quantity enclosed between any two lines. So now that we know what a triangle is, let us know about some different kinds of triangles. We will be classifying triangles mainly on two attributes. First one is based on angles and the second is based on sides. So before we start, you have to know one basic thing about any triangle, that the sum of all the angles of a triangle is always 180 degrees. This is true for any triangle. So now one way to classify is based on angles. The first kind of triangle we have here is the obtuse angled triangle. Now an obtuse angled triangle is any triangle in which any one angle, I am talking about any one angle, is more than 90 degrees. As I have already told that the sum of all the angles will be 180 degrees, and if any angle is more than 90 degrees, then the other two angles will automatically be lesser than 90 degrees. Similarly, an acute angle triangle is a triangle in which all the angles are less than 90 degrees. And we have studied two triangles here. One triangle in which any one angle is more than 90 degrees, which is known as obtuse. A triangle in which all the angles are less than 90 degrees is known as acute angle triangle. And then one more triangle is possible here in which any one angle is exactly 90 degrees. Now such a triangle is known as right angled triangle. Whenever you see this geometrical figure, such a figure in which any two lines are perpendicular, a right angled triangle, one thing should immediately occur to your mind, and that is the Pythagoras theorem. This is a very interesting geometrical figure and it makes up for a lot of interesting questions. We will be covering this in an entire separate video. So for now, you just have to know that based on angles, we can classify triangles in mainly three types: obtuse angled, acute angled, and a right angled triangle. Now let's come on to classifying triangles based on sides. A triangle has mainly two attributes: angle and side. Now based on sides, we have got three triangles here. First one is the scalene triangle, second is the isosceles triangle, and the third one is the equilateral triangle. Now what are these triangles? A scalene triangle is a triangle in which all the three sides of any triangle are of different length. An isosceles triangle is a triangle in which any two sides are of equal length. And in an equilateral triangle, as you might have guessed, all the three sides are of equal length. Now, for each of these triangles, scalene triangle, isosceles triangle, equilateral triangle, we now know that we have in a scalene triangle, all the three sides are of different length. Similarly, in isosceles and equilateral, two sides and three sides are of equal length. But these things can also be extended to angles. So viewing these definitions in an alternate way, we can say that a scalene triangle, all the three angles are different. In a scalene triangle, I have already said that all the three sides are different And now I am stating that all the three angles will also be different. Similarly, in an isosceles triangle, any two sides are of equal length. That also means that any two angles are equal. In an equilateral triangle, all the three sides are equal. This also means that all the three angles will also be equal. As we already know that the sum of all the angles is 180 degrees, therefore if we take three equal angles, it will mean each angle is of 60 degrees. So now let's visualize some of these triangles. Now all the triangles I have got on this side, these three triangles, let us have a look at them one by one. For example, this triangle, here one angle is 50 degrees, 60 degrees, 70 degrees. All the three angles are different, so we can say this triangle is a scalene triangle. Take this triangle. We have got 7.7 centimeter, 9 centimeter, 5 centimeter. All the three sides are of different length, and as you can see, all the three angles are different as well. So this triangle is also scalene, and similarly this triangle having 6, 8 and 10 centimeter sides, this is also a scalene triangle. Now let's come to these three triangles. This triangle we have got, this side is 20 centimeters and this side is also 20 centimeters. And if you have a look at the angles, you will see that the angles opposite to the equal sides, for example, this is 20 centimeter and the angle opposite to this is this angle, which is of 40 degrees. And the angle opposite to this side is this angle, which is also 40 degrees. So we have got two sides which are equal in length and two angles which are also equal. So we say that this triangle is an isosceles triangle. Similarly, we say that this triangle is an isosceles triangle because here we have got both the angles as 55 degrees. Don't worry about this third angle. It might take any value. If any two angles are same or if any two sides are of equal length, you can say that the triangle is isosceles. Similarly here we have got 2 centimeter, 2 centimeters, 70 degrees, 70 degrees. So this triangle is also isosceles. Now come to this triangle. This is an equilateral triangle because here each angle is of 60 degrees. Any equilateral triangle will have all of its angles as 60 degrees. And you also know that all the three sides will be of the same length. Here I have taken a value A. Now this A does not matter. It might be 10 centimeter, 1 meter, 100 kilometers. But as long as all the three sides are of the same length, we say that the triangle is equilateral. Now let's have a look at some of the basic properties of a triangle. The first and foremost thing which you should know about any triangle is that the sum of all the angles is always 180 degrees. This point has been articulated already. The second thing, and it is a very important thing, questions are mainly asked from here, is that the sum of lengths of any two sides of a triangle is always greater than the third side. Now what this means? This means that we can never form any triangle in which the sum of lengths of any two sides is less than the length of the third side. It will be clear after taking this example. There is a question here, have a look at it. Can there be a triangle with sides 2.5 cm, 3.8 cm and 7.6 cm? If we consider these two sides 2.5 cm and 3.8 cm, the sum of their lengths comes out to be 6.3 centimeters. Now as 6.3 and this side is 7.6 cm, we can say that such a triangle is not possible because the sum of two sides is less than the third side. Okay, let's move on to the third property of the triangle. The third property we have got here is based on the exterior angle of a triangle. So what is an exterior angle? An exterior angle is an angle which lies outside the triangle. You can obtain an exterior angle by extending any side of the triangle and by taking this arc. like this. So we say that D here is the exterior angle of this triangle, as this is lying outside the triangle. Now what this property says is that the exterior angle of any triangle is equal to the sum of the two opposite interior angles. In this triangle we have got three interior angles, A, B and C. If we are considering this angle D, this is an exterior angle. We have two opposite interior angles which are A and B. So this property is saying that D will be equal to A plus B. Now this statement can be proved in two simple lines. First thing is that we know that the sum of all the interior angles is 180 degrees. A plus B plus C is equal to 180 degrees. Second thing we know is that the sum of C and D, which are on the same side of this line, is equal to 180 degrees. So you can directly observe from here that D will be equal to A plus B. This is what the property says, that the exterior angle will be equal to the sum of two opposite interior angles. Let's come to the fourth property here. The fourth property says that the sum of all the exterior angles of a triangle is 360 degrees. Now we have studied about the sum of interior angles, which will be equal to 180 degrees. Now take a triangle, for example, where the interior angles are 78 degrees, 62 degrees and 40 degrees. This is the triangle ABC. Now in this triangle, these will be the exterior angle, and exterior angle will be equal to 180 degrees minus interior angle, just like we studied here. D will be equal to 180 degree minus C. So if we add them all up, the exterior angles, they will always be equal to 360 degrees. So we have got 5 properties here. The first one was that the sum of interior angles is always 180 degrees. Second property is that the sum of lengths of any two sides of a triangle is always greater than the third side. The third property was that the exterior angle is equal to the sum of two opposite interior angles. And the fourth property is that the sum of all exterior angles is 360 degrees. So this was all about the theory portion for this lesson. We have studied what a triangle is. We have studied what is an obtuse angled triangle, what is an acute angle triangle, and what is a right angle triangle. And we have also looked into some basic properties of the triangles and isosceles, equilateral and scalene triangles. So now let's have a look at some questions based on these properties and the types of the triangles. The first question we have got here is that there is a triangle ABC, and which is an equilateral triangle. Now we produce the side BC of this triangle to a point D. So we are extending this side BC to any point D in such a way that BC equals CD. Now this side can be produced or extended in any direction. We can extend it in this direction or we can extend it in this direction. Now look at this statement, BC equals CD. So BC and CD, that means we are extending it in this direction. Now A is joined to D, and we are joining this point D to this point A. So we are extending BC until the length CD equals BC, and then we join D with A. Now the question is asking us what is the measure of angle ADC. So we have to find out the angle ADC. Let us draw everything the question states. Now if you consider all the things, the figure will look like this one. We are extending the side CD to the point D. We are joining D to A. Now let's try to solve it. We are given that this triangle is equilateral triangle. So I have drawn these little dashes here, these are indicating that the triangle is equilateral. All these three sides are of equal length. Now CD is equal to BC. This means that AC will also be equal to CD. Try to understand what I am saying here. I am saying that BC equals AC and BC equals CD. So AC equals CD. If AC is equal to CD, this triangle ACD, this is an isosceles triangle. So in this triangle, this angle will be equal to this angle. These two sides are equal, and we have studied about an isosceles triangle that the two opposite angles will be equal. Now the question is asking us for, let's look at this again. Now the question is asking us, what is the measure of triangle angle ADC? What is the measure of angle ADC? So the question is asking us to find this angle. Now we know that this angle is 60 degree as the triangle ABC is equilateral. So this angle will be 120 degrees. I am talking about angle ACD. So angle ACD will be equal to 120 degrees. As the triangle ACD is isosceles, so these two angles will be equal. Angle CAD, this angle, and angle CDA, this angle, which are indicated by the red arrows, these two angles will be equal, as the sum of the angles of a triangle is 180 degrees. So if this angle is 120 degrees, the sum of these two angles will be 60 degrees, and if these two angles are equal, each of them will be equal to 30 degrees, like this. Angle CAD plus angle CDA is 60 degrees, so both of them are equal to 30 degrees. Now let's move on to another example here. There is a question stating there is again an equilateral triangle we have got. ABC is an equilateral triangle and PQR are the midpoints of AB, BC and CA. So we are given four options. This is a multiple choice question. The question is asking which of the following statements will be true. We have to find it out. Let us draw an equilateral triangle ABC. I have drawn one here. Midpoints of the sides of ABC. In the question, it was given that PQR are the midpoints, but I have taken DE and F as the midpoints there. So that will not change the basic properties. Our triangle is still an equilateral triangle, triangle ABC. D is the midpoint of AB, E is the midpoint of BC, and F is the midpoint of AC. So if we join all the three midpoints, we will get another triangle DEF. Now the question is asking here whether the triangle DEF will be an equilateral triangle. Now this geometrical figure is also a special case. You have to remember some things here. I will not go into the proof, but you can remember some things. The first thing is that if you join midpoints of all the three sides, then this triangle, the bigger triangle ABC, will be divided into four equal triangles. Second thing which you can remember is that the line DF will be parallel to this line BC, and the length of DF will be equal to half the length of BC. Similarly, EF will be parallel to AB and DE will be parallel to AC. The length of DE will be equal to half the length of AC and EF will be half the length of AB. So we can write that DE equals, this side DE equals AC by 2. We can write EF equals AB by 2 and DF equals BC by 2. As we are already given that ABC is an equilateral triangle, so AB equals BC equals AC. Therefore, DE will also be equal to EF and EF will be equal to DF. Now, if I add them all up, DE, EF and DF, I will get AB plus BC plus AC by 2. So going back to our original question, it was given that ABC is an equilateral triangle and PQR are the midpoints of the ABBCCA. I took the midpoints as DE and F. Then the question is saying PQR must be an equilateral triangle. We can reframe the question to say that DEF must be an equilateral triangle for this figure. We can already see that DEF is an equilateral triangle as DE equals EF equals DF. All the three sides are same. Now part B is saying PQ plus QR plus PR, which is basically the three sides of this triangle PQR. So we have got DE plus EF plus DF. So this option is saying whether the sum of these three sides will be equal to the sum of sides of the larger triangle. No, this is not the case. If we add the sides DE plus EF plus DF, we are getting half of the sum of all the sides of the larger triangle. So the statement 4, we are given that 2 times of PQ plus QR plus PR or DE plus EF plus DF equals AB plus BC plus CA. So this option is correct and this option is also correct. Let us have a look at a simpler question here. Question number 3. If in a triangle PQR, PQ equals QR. Now PQ and QR are both same. This means that this triangle PQR is an isosceles triangle and angle PRS is given as 110 degrees. Now he is asking for angle P. If this angle is 110 degrees, we already know that this angle will be equal to 70 degrees. As the sum of this interior angle and this exterior angle will be 180 degrees, angle on same side of the line. So angle PRQ, this angle will be 70 degrees. Now as the triangle PQR is isosceles, so PQ equals QR, PQ and QR are equal, these two sides. So this will mean that this angle and this angle will be equal. So if this angle is 70 degrees, then this angle will also be 70 degrees. This is what the question is asking. So our answer will be 70 degrees. Angle P will be 70 degrees. If the question had asked what is the measure of angle Q, we can also find it out. Here angle P is 70 degrees. Angle R, the interior angle I am talking about, is also 70 degrees. So the sum of these two angles will be 140 degrees, 70 plus 70. So the remaining angle will be of 180 minus 140, which is 40 degrees. So angle Q would have been 40 degrees. Now we have another question here. If the three angles of a triangle are 2x, x plus 35 and 3x minus 35, then the triangle is isosceles, equilateral, scalene or the right angle triangle. The first thing is that we are not given the exact value of the angles. We have a variable as x and we are given all the three angles in terms of this variable x. And the question is asking whether the triangle is isosceles, equilateral, scalene or right angled. Now, how would we proceed in such questions? We know only one thing about the angles of a triangle, that the sum of all the angles is 180 degrees. Now if we add all these three angles, 2x plus x plus 35 plus 3x minus 65, this means that we should get 180 degrees as the sum of all the three angles. So adding all of them up, we will be getting 2x plus x plus 35 plus 3x minus 65 equals 180. We will get x equals 35 degrees on solving this equation. Now if we put x equals 35 in the angles, the first angle is 2x. 2x means 70 degrees. Second angle is x plus 35, also means 70 degrees. And the third angle is 3x minus 65. That means 40 degrees. So we have got the angles as 70, 70, 40. Two angles of this triangle are same. And what do we call such a triangle? Isosceles. Let's move on to our final question for today. The question states, taking any three line segments out of line segments of lengths 2 cm, 4 cm, 6 cm and 7 cm, how many triangles can be formed? Now this might look like a tough question, but it is actually a very easy one. It is based on the second property we have studied. The question is asking that we have 4 line segments here. 2 cm length, 4 cm, 6 cm and 7 cm. And we have to pick any 3 of them and find out whether those 3 line segments can form a triangle. Now if we are given 4 things, we can pick 3 things out of them in 4 ways. Let's try to pick them. One way is to pick 2 cm, 4 cm, 6 cm. These 3 things. Another way can be 2 cm, 4 cm and 7 cm. A third way can be 2 cm, 6 cm and 7 cm. Now there is one more way possible, which is 4 cm, 6 cm and 7 cm. So we can pick any of these 3 lines, 2 4 6, 2 4 7, 2 6 7 or 4 6 7. Now let us consider whether these 3 lines will form a triangle one by one. So for example, the first case we have got is 2, 4 and 6. Now if we add 2 and 4, we will get 6, which is equal to 6. From property number 2, we have studied that the sum of length of any 2 sides must be greater than the third side. As 2 plus 4 is not greater than 6, such a triangle is not possible. Similarly, if we are picking 2, 4 and 7 here, 2 plus 4 equals 6, which is also not greater than 7. So such a triangle is also not possible. Now if we take the third case, which was 2, 6 and 7, 2, 6 and 7, in this triangle, the sum of any 2 sides is greater than the third side. Take 2 plus 6, 8, greater than 7, 6 plus 7, 13, greater than 2, 2 plus 7, 9, greater than 6. So such a triangle is perfectly possible. Now there is one more case, 4 cm, 6 cm, 7 cm. This triangle also, if we consider the sum of any 2 sides, 4 plus 6, 10, greater than 7, 4 plus 7, 11, greater than 6, and 6 plus 7, 13, which is greater than 4. So such a triangle is also possible. Only 2 cases are there where we can form a triangle. That's it for this lesson. In the next few lectures, 2 or 3 lectures, we will be learning about triangles in some more detail. Thank you for watching.